entrepreneurship, venture capital, small businesses, and extending and applying superconductivity in industry. We had, in the first part of the session, presentations by each of the panelists. In the interest of time and in wanting to give everybody in the room a chance to ask questions and have a dialogue, we will not repeat the presentations again, but really continue on with the dialogue. However, for those of you who just entered the room, I'd like to introduce the panelists and give you just a brief description of, quote, where they're coming from, what their experiences have been. At the far end of the table to my right, here is Carl Rossner. Carl Rossner is the Chief Executive Officer of Intermagnetics General Corporation in a company about 20 million in sales in the low temperature superconductivity field. Next to him, to my immediate right, is Eric Gregory, who's Vice President and General Manager at Supercon in Massachusetts, a superconductivity, low temperature superconductivity company making wires and magnets, again, a small business in this field. I'm Ed Schau with Brentwood Associates, a venture capital firm in California. To my immediate left is Henry Kressel, who's a general partner of E.M. Warburg Pincus in New York City. And as you may know, Warburg Pincus was an original investor in Hypris and has experience in the venture capital field, investing in a traditional way, but a very high-risk way, I might add, in young companies, and particularly this example in superconductivity. To his left is Paul Kaminsky. Paul is President and Chief Operating Officer of H&Q Technology Partners. H&Q Technology Partners is a investment banking services firm focused on the high technology area. One of the services they provide is putting together corporate partnering arrangements between either large companies and young companies, small companies, or putting together consortia of large companies to focus on high technology research, development, and applications. Finally, to my far left is John Preston, who's Director of Technology Licensing Office at MIT. John was the MIT representative that took the superconductivity ideas from a couple of professors at MIT, contacted the venture capital firm of American Research and Development, and through that activity founded the company American Superconductor Corporation, which you may have read about in the Wall Street Journal today. Just to give you a little background, we have represented here people who have made investments, venture capital investments in superconductivity, who've started companies and run companies in low temperature superconductivity, people who are currently today working in organized corporate partnering arrangements, and university company relationships as well. And with that, I open up the floor to people who want to ask questions of the panel, make comments, observations, and the way I'd like you to do it is to go to the microphone there so that this can be recorded and heard properly, identify yourself, and then ask your question.
My name is Robert Kaiser. I'm with Argus Associates in Winchester, Mass. During the first part of the meeting, we heard the various panelists talk about what they could do for very small fledgling companies, and yet to hear them talk, you'd think they were charitable organizations. And nothing has been mentioned in terms of the quid pro quo that somebody might expect in dealing with a venture capitalist or with another source of funding. And I wonder if the various panelists might not wish to comment as to what their expectations are as a function of the development of the venture. In other words, zero round financing first, second. How much does the entrepreneur keep? How much does he give up, both in terms of equity and control?
Why don't we start here with you, John, and
Sure.
that you've been involved in. And my instructions are to give you the house mic. This is the mic that works. Those are for the videos.
Okay. I'm going to give you, rather than specifics, I'm going to give you ranges that, of what I call zero or even pre-zero stage deals that have come out of MIT in the last year. And you know, I figured I'd start because for me to talk about it's less embarrassing than some of the other people here. And I'm going to make a plug for them. I'm going to say they're worth it. I've seen so many professors with good ideas want to go out and start their own company without any credible or serious investors. In fact, quite frankly, the cheapest way to go out and get money is to go to individuals or go to Europe or even Japan to get investments in your company from those, what I would call unsophisticated venture investors. You get the value of the money. You get nothing more. When you go with a firm that's extremely good at building businesses, you get a hell of a lot more. If you look at the, in fact, one of the venture capitalists in Boston from Greylock, which is a firm we recently did a deal with, went through the top 10 biotech companies based on, top 10 startup biotech companies based on what they're currently trading at on the market. And he went down through every one of those, with the possible exception of Cetus, which was kind of started with corporate money. But every one of them, he identified the individual who was the investor, the venture capitalist. And every one of them was someone who was a senior player in the venture industry. Now, to someone like me, that says something. It says these guys have some good experience in building businesses from the ground up. And they're worth the 40 or 50% that they end up getting ultimately. A typical deal for us would be a company putting in between $500,000 and $2 million, a venture firm putting in between $500,000 and $2 million, an equity position going to the venture firm of 40, 50%, an equity position going to the scientists, the people who are the inventors, because everything I do has an invention involved in it, perhaps unfortunately. But there are some know-how deals that I think are similar to this. They typically get, you know, between 5 and 20%, and the key management of the firm will be reserved the remainder. And there may, in fact, in my deals, there may be an equity position coming to the university in lieu of royalty payments, okay, to license the technology that the university owns. Now, I'll let anyone else who wants to comment. Are those ranges relatively right for
you can only give guidelines of the kinds of numbers that are common in technology investments. And typically what would happen on a first round, which involves $7 million, let's say $3 to $4 million, the management and employees at a company would perhaps have somewhere between 30 to 40% of the company would be a pretty good number. Afterwards, of course, depending on how successful the company is and what its valuation is, the participation, the continued participation of management and the employees will depend on what price they need to pay to attract more capital. Obviously, if they're very successful and they're a real hot company, they have to give away very little of the company to get second or third round financing. If they haven't done so well, they have to give away more. So that's a very big inducement for entrepreneurs who start companies to do a very good job of planning for what they think they would need to reach a meaningful milestone. I mean meaningful not just to them, but to the marketplace and the investors. For instance, the completion of a product, successful beta sites, some backlog, at which point they have shown that a major risk that was present in the first round has been removed, in which case the valuation of the company will be high, they'll have an easy time attracting more capital, and they'll get to keep a bigger piece of the company. Finally, they run through the first round financing, do not achieve meaningful objectives, and the investment community perceives a very high risk, they're not going to do so well. And it's very important to get properly financed and to have the right kind of backing in the first round. I just want to reinforce what John said. it really turns out that if the first round investors are not prepared to carry the company through second and sometimes third round because they just don't have the resources, like your local lawyer or some doctor who has an extra $50,000, and don't understand what the risks they have taken, they may be very disappointed. And at which point you're out in the street trying to get people to come into the company who have not been with it at the beginning, don't know the management. And it's a very difficult fundraising process. So the selection of the first lead investor is a major decision that entrepreneurs have to make, and they have to do it on the basis of track record. And they should do just as much due diligence on their investors as the investors will do to them, because it's a partnership and it's a long-term one.
Just one other comment I'd like to make. I agree with both of those comments, and the supplementary piece is that there are different colors of money. There is equity money to own some piece of the company. And one of the unusual aspects of these corporate partnerships is that the different color of money that comes in through an R&D relationship. From a small company side, that's not equity capital. There would be a piece of equity capital that may come in. That's generally not the principal reason, though. The principal interest of the large company in this relationship with the small, the interest is in the R&D relationship and the ability to infuse the technology. And so from the small company side, the interesting thing in that equation is the good news is that it's a revenue stream. That is, it's not money that's being, this is money being added to the top line rather than being moved from the bottom line for development. The bad news is that there's some restrictions, and that technology is going to go into an agreement, and one better have been careful in terms of arranging that agreement to be sure that applications with which a small company wanted it for are still open to it. It's this market orthogonality I was talking about earlier. In the corporate partnering arrangements, the investments are made with same rules of thumb, but they're almost always minority investments and almost always less than 20%.
I think Carl wanted to make a comment. Now you can hear it, Bob, from the entrepreneur's standpoint.
Yeah, that's precisely why I wanted to comment. I just wanted to give you my own experience, and also having been on both sides of the fence, having originally, of course, been the recipient or a founder stock, but also then switching sides and becoming a venture capitalist. I've experienced the benefits and advantages of and the strength that exists in both parties. Certainly the founders have in their own minds the right to maintain control of the company, have a large share of the stock initially, and they should rightfully at least think about that. But on the other hand, they have to also think through what they're going to do in the second and third phase of financing. In my own situation, we had relatively little say in determining that, in that we, as a spin-off from General Electric reserved the right for itself to maintain 45% of the company in return for having given us access to the patents. And as a GE employee still, I was sort of negotiating with the hands tied behind my back, finally negotiated a founding share of 11%, and an additional 12 or 13% I was able to divide amongst my co-founders and people that went with me. That interest has now shrunk to about 3%. In that we, of course, had to get more money, and then the founder's share gets diluted. In retrospect, I should have obviously negotiated for a larger share, because at a 2 or 3% level of ownership, it becomes somewhat marginal as to whether you will ever get the real major returns that you had accepted. And I think there are two fallacies in this process of negotiating in the beginning. A is the venture capitalist has to be careful not to ask for too much, so that the entrepreneur loses his incentive, in fact, on staying with the company and making it into a big success. On the other hand, many inventors or founders of companies are so possessed by the fact that they have to have control, and they turn down many good venture capital opportunities with very good people. And I echo the sentiment that the first financing arrangement really has to be thought out very well, because as day follows night and night follows day, There'll be more investments required, and then you get diluted. And so it's in the best interest of both parties to really negotiate a fair deal, recognizing the pitfalls of either not giving up too much control. And control is really the inventors or founders or the quality people's incentives to go on and stay with the company until it becomes a huge success, becomes public, because that's the only way when you can cash in. And even then, of course, you're prevented by Rule 144 to cash in very quickly. So the long-term commitment, the long-term view is what dictates what this share should be. And it obviously is different from company to company, situation to situation. But it's important that both the parties understand what the ultimate driving force is of the inventor. And in my case, I've of course been a paper millionaire a couple of times, depending on what the stock market did to our stocks. But the key is, even aside from the money, this is such an exciting technology that I'm almost doing it for the love of being able to build something that, in my opinion, is going to stand the test of time.
Next question. We can't have answered. How about comments, recommendations? Could you use the microphone, please?
Let's see, I'm Rolf Glover. I'm at the University of Maryland. And I want to know, if I return to MIT as a graduate student, will I in fact be doing research from my professor's company?
Here, I want to get the microphone down to
Actually, if you go to any university, any major research university right now, you'll find that a large number of the faculty members are involved in companies, on the board of directors, on the scientific advisory boards, as equity holders. The answer to your question is, if you came to MIT and you were a student, a graduate student, and you felt that you were doing development for the company, that's the exact conflict that we're looking for. And if we find that conflict, we're going to take some action. That in our opinion, is the worst potential conflict of interest for any university involved in licensing technology and helping to facilitate the creation of new startup companies. In the past, universities said, well, let's forget about this. Let's license only to large companies. And as I told you before, the results there were you license 10 or 12 or 15 inventions per year instead of 60 to 100, which we're currently licensing. And you create no new companies, and now we're creating about 5 or 6 new companies a year. So there's a trade-off here. You can say, let's be 100% pure, and you'll inhibit the transfer of technology by being 100% pure. If you say, let's go ahead and transfer the technology, which is actually part of our charter, and the government, the president yesterday said, let's get these research labs to transfer the technology, you're going to create an environment where conflicts of interest can exist. If we have a faculty member who owns a significant amount of stock in a company that we've licensed, we advise his department chairman to monitor his research activities so that we can avoid conflict of interest. And we really attack the problem straight on. We will not accept research money from that company at MIT in that laboratory. In other words, we won't let the professor's company, or the company he owns equity in, fund his own lab. And we'll really try to draw a line between the research activity done at MIT and the development and research activity done at the company. So the answer is hopefully no, and if it were yes, there are people at MIT who would be very concerned about that and would take action.
Could I comment on that, please? Let me comment on 2 ways. One, as a former graduate student at MIT about 30 years ago, and 2, as a current visiting scientist at MIT today. And I think the conflict of interest issue was much greater 30 years ago when the professors did not have MIT's official blessing than it is today. Today, you've cleaned up the act.
I agree completely. There have been over 1,000 spin-off companies from MIT, and only about 50 of them have come through our office. And I guarantee you that the conflicts of interest for the 50 that went out through our office are lower than they are for the 950 that didn't.
Carolyn Meinel with Cardinal Communications. I'm wondering what the change in the capital gains laws are going to do, especially, I haven't checked this out, but do they still give you a hard time about capital losses if you don't have them in the same year as capital gains? What will it do when capital gains are taxed at the same rate as ordinary income? What happens if inflation makes a lot of imaginary capital gains? What does it do to venture capitalists?
I'm going to take the liberty, at least, of making an initial response to this, and maybe other people here have some thoughts about it. It was one of the mistakes in the tax reform bill that we passed last year in Congress to eliminate the differential on the taxation of capital gains. Under the new tax law, they're taxed as ordinary income. We saw in 1978, when we increased the differential, that there was an outpouring of venture capital that we were raising in this country and investing in young companies during the 1970s, when the capital gains tax rate was about 50%. We were putting about $50 million a year into venture capital funds, which was then going into young enterprises. With the reduction of the capital gains tax to 28% initially in '78, and then it went down to 20%, that $50 million a year went to $1 billion a year, $1.5 billion, $3 billion a year. A lot of the venture capital activity that's generated some of the companies you read about today that have become billion-dollar companies in the last several years resulted because of that explosive growth of venture capital. And to my mind, it was turning back the clock to the bad old days to increase the capital gains tax rate. As far as I can tell, we haven't seen the effect quite yet because many of the funds that have been created were already created. But I'm concerned that when those funds get reinstituted, replenished with capital, that it's going to be harder to raise that capital. Secondly, it costs us revenue. The Treasury Department is estimating that as a result of the capital gains tax increase, we lose revenue in fiscal 1988 and 89 rather than gain revenue. Larry Lindsay at Harvard has done studies that have looked at a variety of analyses, and they all point to the same thing, that when you increase the tax on capital gains, you got a one-time spurt, and then you lose revenue relative to the old rate. So what we're proposing to Congress as a way to reduce the federal budget deficit in fiscal 88 and beyond is to lower the capital gains tax again and gain revenue and help to reduce the budget deficit. Does anybody else have any comments on this issue?
Yeah, I just want to make a comment that we were very concerned about that same point, that it would make a difference in the two things. We can't tell you what it means to raising venture capital. We very successfully raised over $1 billion last December, so we didn't have any problems. But, of course, we don't know what the future will bring. However, we have not yet found an impact on the willingness of entrepreneurs to fight for the maximum amount of potential capital gains, even though it's taxed like at the standard rate. People still perceive that an opportunity to be part of a startup and get a piece of equity is a good way to, if it works out, to make a lot of money. I want to point out what happens when some of these companies are very successful. Bridge Communications, which just merged with 3Com, has a public valuation of about $190 million. This company was founded in 1982 or 1981, I believe, with, I assure you, $198 million did not go to build that company. It was a few $1 million, and it was very, very successful. It became profitable relatively early and has grown very quickly. And the guys who were the founders made a lot of money, and so would the employees who joined them later on. So it's that kind of a carrot that stands out for what success really means. And people really so far have not worried about the fact that the taxes will be the same as regular income.
Other comments or questions?
My name is Dr. Ron Barks. I'm with Ronald E. Barks Associates. In the course of product development, most industries would expect this to take a few years from the time it comes out of the lab until the time you reach market introduction. In the venture capital industry, what time frame do you view the product development cycle to take? In other words, how long would you expect to support that effort?
Okay. I think it really depends what your expectations are at the beginning. When we entered into the investment with Hypris, Warwick Pincus and its venture capital partners, for instance, asset management was in right to start with us, had the expectation that it's going to take some years in order to reach maturity, and we weren't disappointed. It's taken some years. And we were prepared for that because that was the investment risk that we took. In general, if you make an investment in a relatively mature technology or one where the product is better in sight, we have found in some of the other investments, at least that I personally have been involved in that at the end of about 3 years, you have a pretty good understanding as to where you are. Typically, the company has introduced a product, the market reception is clear, the value and the quality of the management is clear, and you have a pretty good sense whether you have a winner or a loser. 3 to 4 years is about the time span that most startups will either show that they're going to limp along or they could be real winners.
I might add to that it also depends upon the venture capital firm. Some firms, what we sometimes refer to as mezzanine funds, are investing at a much later stage where the company is already selling a product and it's a matter of time and executing a plan for the realization of that in a public offering or an acquisition merger transaction to take place. So the risk is low and the time period is short. There are other funds that specialize in investing just in ideas, as John was referring to, the stuff that comes out of his operation, where the time from the initial investment to the first product may be several years, and they specialize in that and they understand it, and as Henry pointed out, they know how to monitor the risk and the progress, and they know how to put a plan together based on that, and those are called the seed funds. And then there are some firms that do investments in between or combinations. So in answer to your question, it really depends not only on the people you're dealing with, but also the stage that their partnership is and whether they're looking for short-term returns at that stage or are willing to take a much longer view. Clearly, for this application, superconductivity, you need to be able to deal with funds that not only have deep pockets and be able to work with you over a long period of time, but also have a patience as well, a long view and a realistic view that it's going to take some years in order to be successful. Other questions? Comments? The people in the room with the checkbooks are the venture capitalists. I've been looking around. Let's see.
And if you'd like, I can just elaborate a little bit on what you just said.
Okay.
And,
Be thinking of questions while he's elaborating. There's a lot more to be covered here.
yeah, typically, as you know, I'm only dealing with zero-stage or negative two-stage startup companies. And the longest to the market is a new pharmaceutical, new composition of matter for treatment of humans, where you've got long FDA approvals and so on. Typically, we figure 8 years from the day we license and create a new startup company to the date that we expect to see something on the market. So those would take a company with a lot of foresight, the same kind of foresight on a company like Hypris. In the materials area, we're typically looking at a shorter time horizon to get to the market. In fact, even with American Superconductor, we're hoping to have some ribbons or wires that can be marketed to the research community or to the companies through joint partnerships with companies like what Genentech did in the biology field to get products out fairly quickly. So I would put the range for the zero-stage deals between 3 and 8 years, maybe even 10 years. But But on the longer ones, I'll just reiterate the issue of milestones. If the company hasn't gone into human trials for pharmaceutical within 3 years, or hasn't applied for FDA approval within 4 or 5 years, the venture capitalists may have cause to be nervous and say, wait, you're just floundering, and let's pull the plug, or let's not invest further, or let's try to find some other way to restructure this company. So,
Are there other comments or questions for the panel?
I wonder if somebody could say something about what market research is. It's been said that that's a good thing to do at founding a company. Is that like going to a stockbroker and asking which stocks will double by Christmas?
The question is, what market research, presumably in these application areas of high temperature superconductors, what market research has been done that anybody can comment on?
Well, actually, the way I was converted to an entrepreneur was I was made a member of a market research team, and I was a technical advisor. And what really came out of that study, which took 9 months, was that when you deal with a new product area like superconductivity, where you really don't have good ideas what the ultimate products will be, where the market is, and so forth, that you just have to plunge into the market. And that was really the reason for the experiment to establish us as a garage shop type operation, to try to be in touch with the marketplace and see what people really wanted to do with this technology. And I see that is a kind of thing that probably has to be repeated even in the newer higher temperature superconducting area, in that the market research will tell you if you had certain product characteristics, you might have a market. But the thing that I certainly personally learned is that no technology or no market or a new high-tech company can count on there being a quantum jump or a 10-fold or 100-fold jump from present technology to new technology. There are always relatively small incremental steps on which this growth occurs. And that is, I think, the way that you have to step up to growing a high-tech corporation, unless you have the kind of deep pockets, and those, in fact, are very rare, that people are willing to wait 8 or 10 years for a payoff. More typically, the bulk of the venture capital community, and I think the venture capital representatives that are at this table are unusual, and they take a long-term view. Most expect a return in 1, 2, or 3 years. And so the only way the new venture organization can accommodate that is by setting its targets in an incremental fashion, year by year, and to grow by its own bootstraps and find out what the marketplace is. And more importantly, however, while it's doing that, in order not to go out of business, it also has to keep its house in order. And so the challenge is to operate with inadequate capitalization, with an unknown marketplace, because that grows with the new application of the new high-tech opportunity, but at the same time run a good enough organization that it makes profits year after year, because the profit generation is really the characteristic as to whether you have a well-run company. And as Dr. Gregory is indicating, that represents survival even for small companies. Companies will survive indefinitely if they can year after year make at least a little bit of a profit, and then ultimately attract the kind of venture capitalist or capital, or even go public, that will allow them to really then plunge into the marketplace with the world beater and make this into a very large industry. But the challenge in superconductivity is, in fact, to go gradually in replacing existing applications, both for conventional copper technology with the lower temperature superconductors and ultimately the higher temperature superconductors, and test the market that way if you have products that in fact are cost competitive with the existing products. And that is what superconducting technology, I think, is going to go through and have to go through. And the real winners are going to be the innovative companies who early on recognize the direction in which the applications will go and themselves take a plunge into either have the strategic collaboration that was alluded to, which I think is probably the best idea for the field of superconductivity, in that smaller innovative companies align themselves with larger organizations who then in turn will probably be the first customers. If that is the way these associates should be selected. That if you can have a captive customer, you can at least build a company and build an application and build hopefully a market.
Well, I don't really have too much of a comment here, except, again, to look at the thing historically. I think our main problem, in the superconducting field, ever since the beginning, ever since the 60s, has been trying to find a market. It's been very, very difficult to find a market, in my opinion. We've thought we had a lot of markets, but really the only commercial market that we had until the beginning of this decade was in NMR magnets and small magnets for relatively specialized applications in laboratories. But I think those that were poised in the field of small magnets, which were NMR magnets, were ideally situated when the MRI business came along. But even when that came along, it really wasn't as big as a lot of people thought it would be. And there's always been this concern over whether the industry is big enough for the latest breakthrough. And we've always managed to handle it quite well so far. I think that I was very enthusiastic earlier on about the government associations that we've had, and I think they've worked out very well. I think the problem there has been that, as John Hume pointed out this morning, that there have been successes, but there have also been a lot of areas that were technical successes, but the patient died because there wasn't a commitment and a follow-through for that area of technology. And there are huge areas of technology there. They're very large systems which promise to be new ways of, fusion power and MHD and all these things, which were going to require very large magnets and large amounts of material. They were all technological successes. The question that I think we've got to look at is the fact that we now have superconductors that can go to higher temperatures going to really affect the existing business. I think we're all a little skeptical about that in the short term. I think the more interesting area would be to look at what new areas open up. And that, of course, isn't as easy to do as to look at the past ones.
I think that point that Eric just made is real important, that we have not really put our minds to creative work in thinking of applications for high temperature superconductors. Most of the work that I've seen in market studies has been taking what we've known about low temperature superconductivity and saying, well, if you can do it at a higher temperature, then it's cheaper, it's easier, and so forth. But what new applications open up is we're just starting to think about at this stage. I would like to ask before we take another question, is there anybody here on the panel or in the room that knows of some specific market studies, however, that have been published and people can get access to?
Well, I'm in the process of...
Could you stand at the microphone, please?
Okay, one of the things I'm working on right now is with Dr. Harry Fair of DARPA. I'm co-authoring with him the keynote speech for the 10th International Magnetics Conference coming up in Boston the 21st of September. And a big glaring thing that's been left out of this whole conference is the high power, high speed propulsion. We're going to use the specific case of Earth to space transportation, but as part of this I decided let's not just do another one of these techie things saying how we do it. Let's say what we're doing is we're doing an economic analysis of why how you determine that a technology has matured, hence allowing you an opportunity to go into a new technology. And we use several analogies. We go all the way back to the Ming Navy versus the Vasco da Gama and Prince Henry the Navigator of Portugal. But the most recent one that's current, that's very painful, is the comparison between the aviation industry, which has shown a steady increase continuing up to the present of improved payloads and decreased costs. The Earth-to-space launch and also chemical propulsion of artillery, which both rely on the chemical reactions and then the expansion of these gases, both those technologies have shown a plateau. In the case of rocketry, the big news, the Soviet Energia rocket, big deal, I say, because they had one with as much payload in the 60s and abandoned it, and so did we, and we abandoned ours too, the Saturn V. The cost per pound of the shuttle, and there are good economic analyses have been presented to Congress by some people. It used to be in your district, I think, American Rocket Company, but they moved down south, show that the cost per pound of the shuttle is higher than the Saturn I and about equal to the Saturn V. And this is the payload. When you see both payload size and payload costs essentially flat from 1965 to the present, you say, okay, here is a big gaping opportunity. And then you look at the mathematics and you say, what is the equation for rocket efficiency? It's an exponential function of the change in kinetic energy and the specific impulse. And whereas ideally you only want to pay out as many joules as the difference in kinetic energy from your starting place to your ending place. Well, what technology can get you closest to that? Well, maybe you could use a superconductor. And maybe you exploit a basic superconducting capability that is normally considered a real problem, and that is its tendency to quench. You have three quench mechanisms: heat, current, magnetic field. You can use one of those three to cause a magnetic field caused by a superconductor to suddenly collapse. Now imagine a solenoid.
You're not going to get in trouble giving the speech.
No, this is nothing classified here.
Okay, but
look, I could stop if you're bored.
What's your theme? What's your theme?
My theme, the theme on this is big gaping opportunity. You have one, a stagnant technology, chemical propulsion, all the way from artillery to rockets, across the board. The limit is the speed of sound of a hydrogen plasma in a vacuum, and that's and after that you can't get the specific impulse down any further, and we've really plateaued. Okay,
and this provides an opportunity to go beyond that.
Right. What I'm saying is that using a superconductor, quenching it basically imagine a solenoid, a conductor pulled into the solenoid. Only as the conductor reaches each coil, one of those three quench mechanisms, and that's just a matter of engineering, as we like to say when we're at the 0th stage, causes it to quench. The field collapses, so it keeps on getting pulled on ahead, and each field collapses, and then all the fields are gone, and it goes out the muzzle 20 kilometers per second, 50, 100. The sky, or rather I should say the speed of light, is the limit, and the theoretical efficiency is that of 1/2 mv squared. So.
Is that one of the items in your matrix?
Item number one.
Let me just go back for a second to the market issue, which I think prompted this discussion. Just a couple of quick comments on the market. When you have a radical new technology, it's very difficult to predict what the first successful application is going to be. And I want to reiterate what was said before. You need to be close to the market and keep your ear to the ground and be willing to modify your products very quickly in response to user needs. Let me give you one example. When the transistor was invented, within 5 years after the invention of the transistor, the weight of vacuum tubes was cut in half, the size was cut in half, the cost was cut in half, the energy consumption was cut in half, and you had people thinking conventionally, well, the transistor is going to replace the vacuum tube. But what did the vacuum tube industry do? It redoubled its effort in the old technology and responded beautifully, kept the transistor out of its markets. However, someone at TI figured out, well, wait, there's a market for the transistor that doesn't exist, that doesn't have a vacuum tube right now, and that market is a hearing aid. And the hearing aid was the first commercially successful market for the transistor, and got the volumes up to the point where TI could compete in other markets. And so the point here is that in the superconductor field, I think a lot of us don't have any idea what the first successful commercial market for high temperature superconductors is going to be. It may be squids, as we've heard today. There are a number of things. What companies like American Superconductor plan to do is just put samples of wire out to development people to say, here's something that's reasonably ductile, play around with it, and see what the users actually invent, and then be close to them and responsive to them. And the joint venturing, the Genentech model of joint venturing with large firms is one way to get close.
Other questions?
My name is Saul Feldman.
No, I think it's live, but it's going into the video.
Oh, I see. My name is Saul Feldman, and I'm with a company called Applied Superconductivity. And I have a question for the panel. I don't know if anybody cares to answer. Suppose a company has a choice where enough has been done in the garage, so they have a plant that is sellable both to some of the people in the panel or companies that they represent, and also to some really low-level underwriting, sort of in the scum in Wall Street.
Is this a loaded question?
No. I wonder whether anybody cares to comment on the pros and cons of that sort of those two choices.
Is this a hypothetical?
Could or could not be.
Is this concerning your company, for example?
No.
But
I think it's a question. Before getting involved with this thing, I was a management consultant for many years, and these questions arose many times over the years, and I wonder how some of the people may feel.
You know those Wall Street people.
We're in Lexington and 46th. I've been asked that question very frequently by people who do have the opportunity to have what's called penny underwritings. And I would say, in all honesty, if you think all you're ever going to need is one infusion of capital, and you're never going to have to go back to the market again, and you really don't need anybody's advice, and you want to run your own show, and you also think that the stock will be appropriately supported, that someone's going to make a market in it, and you also think that you're going to be able to sell your share of the company to somebody someday. There's a lot of ifs. In that case, I think it's a great idea. If you, on the other hand, what happens with these small capitalization companies is you tend to be locked in, and at some point the insiders would like to, sell some of their stock, or you wish to raise more money, then you really are a very hard time. You have to go back to the public markets, and if this is a company that has a stock that's not well supported, that doesn't have really a broad distributorship, it's very hard to sell it. You have to go through a lot of pain to have another offering to add to it. On the other hand, it does provide, it's nice. You don't have any one group of investors with a large stake in a company and to answer to. So some people like that. I'd say by and large, I think a good venture capital route is a better way to go. Because I don't believe the conditions that I've stated before will be satisfied. If all of them won't be satisfied, perhaps one or two will. From the point of view of the value of being a public company when you're very small in a thinly capitalized marketplace.
Is another way of saying what you said, that if that thing becomes a roaring success, then there's no problem.
There's no problem.
But if it isn't, with 90%,
Yeah, it's tough because your flexibility, see, the moment you're a public company, you have to report a lot of things. Your degree of freedom as to what you can do with your company, discussions of mergers, investors, buying and things, you have to report it. It's like being in a fishbowl. You have a lot more flexibility. The other thing which you need to worry about when you're a little company like that, you will push for profits, short-term profits, in order to, because you're watching your stock, and if it is profitable, then there'll be more activity, more interest. And very commonly, you'll do this at the expense of the longer-term future of the company, which is when you're private, you really have a lot of flexibility.
What about taking the other road or not paying attention to profit in initial times if you think you know what you're doing?
Well, would you like to have a stock offering where you sell the stock to your friends at $5 a share and it goes down to 50 cents? That's not a happy prospect. It's a good way to lose friends.
Number one, I have written an article on that, which I'll be happy to make available to anybody, that was published in Electronic Business.
Could you identify yourself?
Oh, I'm sorry. I'm Ken Rind, Oxford Partners, venture capital firm. But secondly, I think the major thing one should think about when one is considering whether to accept money from a public offering or from a venture capitalist is that really the name of the game is what price you're going to get when you sell your own shares, not what price the company gets when the company sells its initial shares. Because it may very well be that the initial shares get sold at a higher price to the public than to the venture capital community initially. But the encouragement and backing of the venture capitalist may allow you, when you want to sell your shares, to get a higher price for your shares. And indeed, one can very easily make a case that that is the truth, and that therefore one is much better off accepting money from a venture capitalist at a lower price than from the public at a higher price for that initial raising of financing.
I think many of the questions and answers that have been discussed back and forth in the last half hour or so are really applicable to all kinds of companies. They're really generic to new technology, new businesses, and the financing thereof. I'd like to ask some questions of you people out there. What really is important about this new high-temperature development, it's really totally different from just having a new idea in technology or for a new product or something. We have something akin to really the startling development of a Sputnik appearing in the sky, for example. It has that kind of a dramatic potential. And I think what I would like to ask, how does government, industry, and the university community react to something like this in this country, where it may no longer be really possible to rely on individual initiatives or individual inventors to try to go and find their financing. This is a much, much bigger problem. It will take years and possibly decades to develop this technology until there is a multi-billion-dollar market. And I think it behooves us to really seriously think about the mechanism that venture capital has to supply to this kind of a technology in contrast to the typical venture capital deal. And I think we need some guidance and some communication to make this particular technology successful in a totally different environment than what we've been used to date. Because the impact, if we lose, and that's really the rationale behind this conference, is where is the competitiveness of the United States going to be 10 or 20 years from now, if indeed superconductivity develops to the potential and more likely develops overseas, either in Europe or Japan, with the kind of long-range views and long-term expectation and the willingness to invest in the long-term growth of the country and the technology. Where are we going to be if we don't find new mechanisms and new measurements to evaluate the potential of this technology and the willingness to find either Wall Street or venture capitalists to invest for the long term and hopefully also wait for the long-term returns that hopefully will accrue if we do the job right?
I'm Frank Druding from Ford Aerospace, and I've been sitting through 2 days of the conferences and listening to those kinds of speeches, and at the same time listening to how we can't define application and potential. And I guess I'm pretty concerned that we may have picked a playing field to be worldwide competitive in that's an extremely difficult one, and in fact may not have any significant impact any more than it's had to date in the future. And I'm just trying to find out why so many people are standing up and talking about the great potential without the ability to define it.
Who wants to answer that? I think the question that's raised is, and I got this response as I contacted people around the country who are in venture capital firms, is that there may be less here than meets the eye. That there may be a lot of hype and newspaper stories and indications that we're almost there, and that could create a series of investments or actions or redeployment of resources at the private sector and public sector level that turn out to be mistakes because we haven't thought it through in the cold light of day. And I appreciate your raising the question. It deserves an answer. I don't happen to have one, but challenge the panel to deal with it.
I'll give you guys some time to think about it. But I think that any radical new technology stands a good chance of falling flat on its face. And I've got a friend at MIT who says gallium arsenide was, is, and always will be the material of the future. And but partly right. He probably is right.
Awful memories.
Exactly. Yeah. But at any rate, he says, that silicon and gallium arsenide have improved in their cost efficiency and measured in terms of time response and so on at about parallel curves, but one's had 10 times as much money pumped into it than the other one has, namely silicon. In fact, I think it's more like 100 times as much money pumped into it. The area of superconductors, I would say that from a venture point of view, there probably are not as many deals out there as the venture community would like to think there is, or universities would like to think there are. We've received, as I said, over the last 6 months, maybe 10 invention disclosures related to superconductors, and I really didn't see any way of building a business out of 9 of them. Out of one, yes, making the stuff ductile and putting it in the hands of people and seeing if they're applications-oriented people could come up with some interesting ideas. That looks like you can build a business out of it, and if nothing else, it's going to supply a need in the research and development community to play around with this and see if it's real. But as with all radical technologies, if you don't dream a little bit, if you don't say, well, we may be able to ship energy from one location to another just by starting a current flowing in a coil, or you may be able to average out energy loads by having big magnetic batteries, or transmission lines at lower energy cost by 5–10%. That's the kind of dreaming that I think maybe those won't be the ultimate applications, but they'll at least pump a little bit of thought and a little bit of money into this area, and maybe something good will come out of it. And like I said with the transistor, it's very hard to predict where the first commercial success will be. But if there is something really radical to the technology, maybe it will be in the public interest and good for all of us that we are having this conference and are throwing some intellectual power into this area, if nothing else.
I like to.
Putting so much
Yeah.
government prestige and emphasis and position in a technology and a field to enter an international technological race, that even if you win the race, there's no prize and nobody cares.
No, I like to answer that. I have a chart that I didn't show an answer to that question because of time constraints. Great.
Can you talk into the microphone, Carl?
Let me try to address the question in a perhaps somewhat larger context, and the reason that there is the kind of environment and concern and challenge that we have upon us. If you look at the modern society, it is really benefited by a number of basic technologies and basic situations. The electrical industry certainly is at least responsible for the revolution in society in terms of electric motor, and the electrification of society certainly is an important advent and represented a major change in our environment. What we are dealing with are really the fundamental elements of the electrical industry and the electronics industry, in that the interaction of electric currents and magnetic fields are what make every motor work in this country, every generator, every power transmission line, every device or appliance you have in your home. And likewise, the ability to conduct or semiconduct or control the conduction of current makes it possible for any electronic device to operate, and is of course behind the electronic revolution that I think we've seen in the last decade or two. What this new technology represents is to, in fact, as I've indicated on the right-hand corner here, to obsolete and to provide opportunities for regenerating radically new devices and radically new technologies, and so that the general impact is not yet known. It's a little bit too early, but we have a fundamentally new phenomenon, a perpetual motion machine type concept. Before, or we have a device potential that hasn't existed before, and to argue that we shouldn't go after it with a vengeance is, I think, what President Reagan referred to, that we are at the stage where it's very easy to say these new ideas won't work, and then you go to the next step and they say, gee, maybe they can be made to work, or ultimately it was really a good, my idea was a good idea in the first place. I think unless we go through these stages in a determined fashion and address the kind of both basic fundamental science questions and the developmental questions, as I was trying to indicate on the other chart, is we certainly aren't going to live in a society that is up to par and is competitive with the rest of the world. Definitely, I think the scientific community and the technical community and the industrial community will go after these new devices and the new opportunities as they exist in the new both low temperature superconductors and higher temperature superconductors that we hope to have in the future. The last comment I wanted to make is the electrical phenomenon that exists today, the interaction of electric current and magnetic fields and semiconductor may in fact in these new high temperature superconductors exist in the same device. We may have a semiconductor that is both a semiconductor and a magnet and an electrical device in its own right. So it has three different kinds of properties that I think we have to develop, and I have in my pocket what I jokingly refer to as a model of a room temperature superconductor. And what that is, it looks like the black superconducting materials, but it's really a permanent magnet, you see. And this is one of the rare earth type permanent magnets that will become available as well. We don't quite know yet where these permanent magnets are going to be applied for or applied to. And I think the same is with this new phenomenon. We have to really challenge our imagination. And I'm sure, as a wise scientist told me many, many years ago, we have a tendency to be overly optimistic in the short term and much too pessimistic in the long run. And I think the same thing will hold true now. There's a reaction setting in to the hype that existed in the media and some of the magazines, and suddenly the near-term expectations may look a little bit more difficult. But I can assure you, I'm convinced, and this is a gut feeling, of course, and that's what propels entrepreneurs or inventors, that they see glory way down the road. And I think it's like people climb mountains. They climb the mountains because they're there. And I think that is a challenge I think that we all face in this particular technology.
Other comments? Somebody who hasn't commented before or asked a question?
My name is Roger Barton. I'm from Stanford University. I wonder if the panel members would care to respond to some parts of the President's initiative. In particular, do you have any experience working with companies that may have considered exclusive licenses from the federal laboratories?
The question was to comment on the President's initiative, and in particular the aspects of the initiative that deal with licenses granted to the private sector from federal laboratories. Does anybody here have any either direct experience, observations on, I guess your question is, how well does it work in practice? I think you were to go to another session to get the answer to that. There's one on tech transfer.
Yeah, but both Stanford and MIT and many other universities have been granting for a number of years exclusive licenses to companies on government-sponsored research. And those exclusive licenses are granted but for the right to of the U.S. government to have a non-exclusive royalty-free license to that technology. And I would say that it's been very successful. I can run through lists of companies. Symbolics, which was licensed 7 years ago from MIT, is now a $120 million company. I can even there's a new light bulb on the market that's coming out of Lincoln Lab technology that reflects the heat back to the filament. So for 65 watts of electricity, you get 100 watts output on an incandescent bulb. I can just run through hundreds and hundreds of products that have been successfully licensed on an exclusive basis, not just from my university, but from yours, for government-sponsored research.
Sort of a loaded response, but do you think it would work as well from Argonne or Oak Ridge?
The question was, would it work as well from federal laboratories as opposed to universities? Does anybody have a comment on that? And it's not just the panelists. Are there people here in the audience who have some experience?
I could just say, while the audience is thinking about this, that Lincoln Lab is in fact very similar to Argonne and Oak Ridge. And among the Lincoln Lab spin-offs are digital equipment. The newer ones would be companies like Proteon, Lasertron, Micreon, all these ION ending companies. But they're accounting for tens of thousands of jobs in the New England area right now. So maybe someone else could comment.
I think one of the key items in technology transfer is whether the inventors or the innovators make the decision to go into the startup or not. I think to transfer technology on a handoff basis out of a laboratory into a commercial entity without the inventors being a part of it is not an easy process. And I think the examples that you gave of Lincoln Labs, at least some of which I recognize, like Micreon, the guys who were involved in the I-beam technology did leave. The same with
all of the cases.
Laser
I
comms.
gave some people left. Digital equipment, 5 people left to start that.
So I think that if you ask the question, will it work at Oak Ridge or at Argonne, no reason why it can't. If the people involved make a commitment to leave, and I bet you can find examples that people have left these laboratories to set up companies.
With the white shirt. Sure.
Feldman, I wonder whether maybe Mr. Preston could comment on this. In terms of the royalty-free license for the government, I understand, for example, if the government wants to take some development by some company and give it to another company, they are free to do that. And if you give them the blueprints and those are sufficient, good luck. Now, but however, other than that, what does that imply? Take Symbolics. Symbolics sells computers to the government. other than getting on the GSA list and like anybody else and coming up with some competitive price or discount, what else is implied? I wonder if you can explain that, the royalty-free license, in cases like that.
Yeah, the one thing that the royalty-free license to the U.S. government, well, what it does is it gives the U.S. government the right to find a second source to manufacture that technology or that invention. MIT has given the government, through an agreement with the government, has given these non-exclusive royalty-free licenses for all inventions that we've licensed pretty much over the last, well, since about 1932. To my knowledge, the government has never exercised its right on any of these inventions to find another manufacturer. However, it's a mechanism that the government can use to make sure that Symbolics does not, charge much more than it should charge on shipments of the computers from Symbolics to the government. If the government did take it, quite frankly, all of the technology coming out of MIT, Stanford, and all of these universities is in such a fundamental form that you need to have, as was pointed out, you need to have people transfer, a considerable amount of know-how transfer. Symbolics, I think, took about 30 people out of our AI department, including students, to start that company. And I think it would be a non-trivial thing to go out and try to build a competing product, even with the MIT designs and even with the MIT Lisp code. And so
the negative potential for the company is almost non-existent, practically.
Yeah. The negative potential for the licensee is almost non-existent, especially when you also factor in the fact that if the government did transfer that technology to a third party, that third party would only have rights to sell to the government. So it excludes all of the private sector market. And so an exclusive license, and I think this is exactly what Reagan wanted to do, an exclusive license from a contractor to a company is worth something if the technology is good and if it's protectable, because patents may or may not be good, but know-how may be the overriding factor.
Henry has told me that he would like to comment on the question that was raised earlier about are we putting too much emphasis on superconductivity and perhaps to the detriment of other valuable activities?
I won't debate the question whether the visibility of this breakthrough has been too high in the public press. I think it's unprecedented in all the years that I've been in business, including having lived through the invention of the semiconductor laser, tunnel diode, CMOS, you name it, things that we now take for granted. I don't think I've ever seen people publishing papers in the New York Times. And I certainly don't welcome that as a good development for the scientific community. I think it's detrimental in the long term. I think expectations are too high for short-term results, and I think that's bad. On the other hand, I think that this development is so potentially of great magnitude, because I think if you answer questions, if you can do the following properties can be met, and I think the last 2 days we've heard a lot of things, a lot of what-ifs, which we just don't know if it's possible or not. It's important enough that we should put significant resources behind it. And historically what's happened in the United States, as it's happened all over the world, this is not unique, the high-risk funder of very leading-edge technologies is the government. And I can go back on the development, the early development of integrated circuits. The government played a leading role in that. Semiconductor lasers and fiber optic communications, having lived through this one, I guarantee you that these products would not have been developed in the United States, and not even in Japan, at the rate they have, if it had not been for some adventuresome people in the government who saw the potential at the time when the semiconductor laser would live 5 minutes, but saw that if it did live and if it did work, it would revolutionize communications. And early funding made the difference and proved that it was possible. So I think to answer the question is, yeah, I don't like the hype. I think it's excessive. But on the other hand, I like the fact that there's going to be a significant initiative and put in the hands of some very, very skilled people in the government, very experienced people who have been through this field before and will give a big impetus to the field. And I think what we're going to find out that the easy work has been done, and these contract monies will find their way into very skillful people. And we'll know some answers 6 months from now, a year from now, and we'll have more answers 2 years from now. But we just simply cannot afford to say, gee, you know, it's going to go away. Because our competitors in Europe and in Japan will be running real hard, and I think we can beat them. But unfortunately, it's going to take a real dedicated effort. I'd like to ask Dr. Edelsack to perhaps comment on that, because you were involved in the very early years when people couldn't figure out what to do. Some stories you've told me about applications of some other technologies in the medical field, like accelerators, and how you view that.
Well, I was with the Office of Naval Research for some 20 years and initiated the programs in superconductivity, and my illustrious boss, who's sitting in this room at the National Academy not too long ago, cited that as a major failure. And the reason, and he was right in some way, because...
I was kidding.
Well, there's a certain truth with it. We poured large amounts of Navy money, and there is today nothing in the fleet which is operational and is superconducting. On the other hand, that technology is a great success. All of what Sam Williamson presented today, all the biomed uses involving magnetometry, came out of the Department of Defense support. It happened to be for ASW, but we're not detecting submarines today, but we will. So often, why we fund the technology may not be its ultimate goal, but not to fund it is a major error. And that's the theme. I think we have to fund it. Maybe the anisotropy in these superconductors will be the application which isn't even on Carl's chart, or maybe some other aspect of it, but not to fund the basic research, which isn't that much, truly, in terms of DOD costs. The President speaks of $50 million a year. DOD now spends $50 million a year in superconductivity, so it's doubling the DOD budget. That's really not that much, $100 million a year in superconductivity. Thank you.
Yes.
I'm Chuck Craig with Defense. I also once worked for Donna. And I thought it was curious just now when Dr. Rosner mentioned the macromagnets, and Ed stands up, and I don't know how many of you noticed, but he has a pair of them in his hand that he's playing with. And I have a paper written by Norm Coons at NRL titled Background Information on High-Performance Permanent Magnets. And I worked with Defense in technology security, and I look at cases and materials that are being exported to the East Bloc by and large. And I was looking at a case that was potentially to be exported, and that's how I come to have this paper. The Air Force, about 10 years ago, 15 years ago, developed samarium cobalt as a material under Air Force funding and so forth, which evolved into the current state-of-the-art for the high-performance permanent magnets. And then it went to Japan. Now, Norm Kuhn and others have developed, I believe Norm actually holds the Navy patent on the class that includes neodymium iron boron, which I believe is what you're referring to.
Right.
And those have been around for a couple of years, and no one has really found a market except General Motors, Delco Remy, Magna Quench Division, because they were in there in the long term at the GM research labs, looking at those materials, watching what was coming down, found an opportunity, and have put tremendous amounts of money into a new facility up in Indiana, I believe it is, and are capitalizing on this technology. They have a source, they have an opportunity to use it, the technology is there. I believe what Dr. Rosner was saying a few minutes ago, and this is really the only reason I wanted to stand up here, was that those opportunities are out there. We didn't have samarium cobalt 15 years ago. There was no market for samarium cobalt. Then there was a market, but the samarium represents, as in the 2% of all of the rare earth deposits in the world, and neodymium is in 98%. So we're looking all of a sudden at a dramatically reduced cost for these magnets and an opportunity to forge ahead. And if they're superconducting on top of that, won't that be wonderful? Thank you.
Thank you very much.
My name is Bob Kaiser of Argos again. In response to the comment by the gentleman from Ford Aerospace, one thing we should also note is that in terms of superconducting materials, we have two classes. One which we've known something about for a long time. The second class, the 1,2,3 oxide class, just came about within the past year. Who says that you don't have other materials out there that may not have a combination of properties that will allow you to do what neither of those two classes may do? I think what the President's initiative has done is focus on the technology. And I think what the discovery of the new class of superconductor is open up a dream. I've gone to scientific conferences for many years now. It's been a long time that people have gotten excited. There's hype, but people, I think, are feeling very, very excited. I was stopped in the elevator just because I had a badge to this conference by somebody here at the hotel. And he says, "Oh, you're one of these superconductor boys," knowing full well that I'm not. But he says, "Wish you luck." People are interested. People are excited. It also means that money will be available. I think in the short term, I think the people who will really benefit from it are the conventional superconducting magnetic people, because they're closer to end products. They know what their materials are all about. And suddenly people are going to refocus on the field, and suddenly we're going to have gadgets and widgets which would not have been made available if this initiative was not there. Once this is going, little bit by little, some of the other new materials will come filtering in. And as people get to know what they can do and what they can't do, either they will be applied or people will search for alternate solutions. I think it's money well spent.
We may have a case here of violent agreement because I think that everybody who has been taking one side or the other of this debate, which is a debate that's real important, has come to the same fundamental issue, and that is there's a danger of overhype in the short run if what it results in is people getting discouraged, or if it results in wasteful spending on projects that haven't been carefully thought out. But the advantage of the interest is that it gives us an opportunity to realize those dreams in the long run. And so we just have to be realistic. I think you'd agree that we have to make sure that we understand this difference between short-run hype and long-term commitment in order to make it successful. It is amazing, as been indicated, how many people in the United States of America through the popular press have become educated, at least to a small extent, on superconductors. Before January of this year, they thought a superconductor was somebody like Arthur Fiedler or something like that, and now they have a real interest in science that could ripple into the schools and get a lot of young people encouraged to go into basic science. Carl?
I like to support some of the comments that are made, and I think the characterization of violent agreement certainly is a correct one. But also, I think an interesting point was made that I want to strengthen even more so, and that is really when it comes to very high-risk kind of technologies and high-risk programs, the really best and best equipped venture capitalist is a government. And in particular, since the government has the resources and has a long-term vision, certainly founding fathers had a long-term vision 200 years ago, there has to be somebody who's not looking out for this year, next year. And so it's quite appropriate that the government is building a fire under us, both in industry and in government and in the university community, to try to find a way to overcome this new frontier that just has been discovered. And the reason for the I think widespread hype, if you like, or excitement, is that for the first time this is a breakthrough that doesn't just affect one singular industry. When the semiconductor was discovered and applied, it went into the electronics industry first, of course, and excited those people. Today we have excitement in a number of industries, all of whom had sort of grown tired and didn't know where the next challenge was going to come from. The ceramics industry, for example, was looking at losing its advantage and all ceramic technology to Japan. The ceramics industry has been given a new lease on life, a new challenge. These are new ceramic type superconductors or materials. And so they are interested in pushing for all it's worth. The electronic industry, the electrical industry, the physics community had run out of problems almost. Where was the next frontier going to come from? What were they going to do after nuclear power problems were solved? The accelerator, the superconducting super collider, for example, represents that kind of frontier. That's why the entire physics community supports that superconducting super collider so much, even though it's a multi-billion-dollar project. And so it goes. I think what we are seeing is really a galvanization of not just one industry or one technology or one discipline. We are seeing something that is pervasive in its impact and hopefully pervasive and universal in its payoff ultimately down the road.
Yes. Fred Levitt from the White House Science Office. I'd like to go back to the little guy, if I may, for a moment. There is a government program which has not been in existence that many years, but I'd like to see if any of you have seen any, have you seen hide nor hair of the Small Business Innovation Research Act? Has it brought any of the small inventors up to speed to the point where they come to venture capitalists? Is it a success? Is it even visible?
Hey, I'm going to hand this off, but just to clarify the question, a few years back, the Congress passed what they called the Small Business Innovation Research Act, which required various departments to set aside a certain percentage of their R&D funds to go into seed financing of some small companies, and that if after that seed financing was successful, then there would be additional funds in partnership with private funds. So it was a way for the federal government to actually do a little bit of venture capital. Eric?
Yeah, I'd like to respond to that because I think we are one of the many companies maybe that have found that scheme a very, very helpful one. Last week I was in Washington here reporting on the first two of those projects, and I think that scheme has been very, very helpful to us indeed. I said earlier on in my opening remarks that the cooperation between the universities and the industry and also the national labs had been what created that slide that I showed over there. I would like to add that we did have a Small Business Administration Phase 2 project, Phase 1 and Phase 2, which was related to that. And when the funding sort of dried up a little bit from Lawrence Berkeley Laboratory, we were able to use our SBIR funds to make that into a success. And so I think we would like to say that we're very dependent on the Small Business Innovative Research Programs. We find them very, very helpful. They've helped us develop new products, which I think we'll be bringing out shortly, which are closely related to superconductors, and they've also helped us a great deal in superconductivity, and I hope that we've helped the Department of Energy by developing some of these things.
Several of our portfolio companies have received SBIR grants, and I think the program, insofar as what I can see, is very, very successful. It really, for $50,000 or whatever the number is for a initial investment for little companies, a lot of money. It's enough for them to get started on some new things. The second phase is very, very well thought out. You have to be able to be on track. To have a product, you need to have a sponsor to make sure that you have the financial resources to actually bring it to market, which is I think an excellent idea. And $500,000, which is the kind of numbers people talk about, that's real money. 50,000 may not be so much, but $500,000 is real money to a little company. So I think it's been an excellent program. The second question, the second part of that question, which I'd like to answer, is what's this done in terms of people starting off businesses? We have seen one startup recently that was completely started with nothing but SBIR grants, and those fellows managed to get to do a variety of other contracts, about $1 million, $1.5 million run rate, and profitable. At which point they went to the venture capital community and asked for an horrendous valuation. But I take my hat off to these guys. They really managed to focus in on some things, started from scratch, self-financed it, and show it to everybody that they can get a business off the ground. I think it's wonderful.
Yeah.
I just wanted to mention, trying to speak a little bit about DARPA's ability to help. DARPA right now has a program on superconducting materials manufacture, and DARPA is setting up its own contracting office so that shortly they can get money out real fast and pain-free. And since I get my money from DARPA contracts, I know that they can even today do it fast and pain-free when they're really motivated. So please, if you want to get money from DARPA for this stuff, Dr. Kay Rhine, R-H-Y-N-E, in the Defense Science Office is the one who's holding the purse strings. And so it's easier than you think. If you've ever tried to get government contracts, DARPA is in a class by itself in valuing innovation above everything else.
Lock the doors, everybody will be taking them out.
Andrew End of Oxford again. I just wanted to reflect on the SBIR program. A number of our companies have gotten SBIR grants. It's a valuable program, but it has a major flaw that I'd love to see corrected, and that is between the $50,000 grant and the second phase grant, $250,000 to $500,000, is generally a 6-month waiting period, and that's very difficult for a young company. And there just has to be some sort of interim financing program that the government can think of to bridge that gap for these small companies. They just can't start a program and hold it in abeyance for 6 months while they're waiting for a second phase grant.
Take one more question.
Completely true. At least in the Department of Energy, we don't operate that way. You can get continuous funding.
I'm delighted to hear that. Most of the companies I've dealt with have had their grants from the NSF. And possibly it's different in the DOD and other of the agencies. I'd like to hear about that.
Our experience is with the DOE, and we have found that they're almost continuous. If you put your phase 1 in and get off the ground early, put it in at the first stage, you can almost get continuous funding. The most you'll wait is a month. If you go the longer way, then it may take a bit. With DOE, that's the case.
Comments? Final question?
My name is Bill Walker from company Zestron, and I'd like to comment about the SBIR. Ours is a company that has taken advantage of that program for the DOD, and a lot of the questions about this in this conference have been, what are the markets? We've just read through the SBIR booklet, and we've gotten involved in new businesses just from doing that, and it has led to venture capital.
Great idea.
In regard to the question mentioned by the person from Ford, I have a hunch that if you were to plot the time lag between when something was discovered or decided till the public got to know, and you started with Columbus and you came all the way down to here, I think even this meeting falls on that straight semi-log line. Am I coming through?
You mean the time between
for the transistor and for the hearing aid, and right. And I think what's happening, we just happen to living through a period of that curve, that things are pretty steep and we can't quite be with it. But I don't think it's anything unusual.
One of the perks of being chairman of a panel is to get the last word. It won't be a long one. I just want to thank all of the panelists and particularly the audience for participating in this discussion that covered the areas of venture capital and small business and entrepreneurs and their role in advancing this technology. There is a role to be played. There are a number of models that one can follow. We've heard about those, the traditional venture capital investments, either with SBIRs or alone. We've heard about joint university and private company relationships, and we've heard about corporate partnering as well. What I would like to suggest to my venture capital friends as we move forward and help to fund applications in this area, that we keep a long-term view ourselves. That we, when we put together deals, work to build the basic research and development capability of the country, that rather than pulling people out of research organizations to find ways in which professors can stay in the university but work with the company so that there's a continual critical mass that's being built up in our universities, and that the company's role is to commercialize that and to draw on that basic research, but that we've got to realize we can't force the technology, we can only foster it and maybe help guide it by raising relevant questions. I think the key issue that we were debating, is it too soon? The conclusion is it depends on what you mean by it. It's not too soon to begin dreaming and thinking of applications and helping to work on some fundamental processes. There may be some companies in the offing that can identify, as Henry put so well, specific products that use this technology, or at least raise the questions and be ready for it. But we shouldn't over-expect and then have our hopes dashed on the rocks of reality. We should understand that we're at the beginning of a very long road, but that entrepreneurs and venture capitalists and small businesses have a role to play in getting us to the end of that road. I want to thank you all very much again.